My dear students, welcome to our online classes. I am Ravi Kumar KR, lecturer in Computer Science, Gopal Swami PU College, MYSURU. Today, we will start with our session with the new chapter, that is chapter 5, Problem Solving Methodology. So, the weightage of the chapter is 11 marks, 1 mark 1 question, 2 mark 1 question, 3 mark 1 question and 5 mark 1 question. So, total weightage of this chapter is 11 marks. Students, thus the problem solving methodology. In this chapter, we are in the field of computer science, we are going to study this with respect to our programming concepts. The term, the problem solving, is used in many disciplines. Or in many fields. So, for example, in the field of science and engineering, in the field of education, or in the field of commerce. You take example like this. In the field of science and engineering or science and technology, this problem solving deals with mathematical problems. Mathematical related problems. I am here, it involves solving many complicated problems, complicated solutions, complicated formulas and so on. So, with respect to education or in the field of education, you take example of universities. See, every year in any institutions under MYSURU University, we have many different colleges all over Karnataka, isn't it? Or located on different locations. So, every year many students, number of students are getting enrolled under MYSURU University, and every year many of the students will come out of university. So, here you can imagine that, see, at every year number of students walking into or getting enrolled in university colleges. At the same time, many students, by completing their degrees or education, they will move out of the university. The problem is to maintain the records of each and every student in the university. Now, you can imagine the number of students, or you can look at the numbers. It is very large numbers. A university, they have to maintain the records of all the students of so many years. It is not only for 1 year, because since any institution or university has started, from that day onwards till date, so the universities or education institutions, they have to maintain the data of students. So, that is, the data is very voluminous, or it is a very large data. Next, it comes to commerce. In the field of commerce or in the field of business. In the field of business, you know that you take example with large companies, they have to maintain the records of each and every employees. So, if there are lakhs of employees in a company, so the maintaining a record of each and every employees, and not only that, if it is a manufacturing unit, so they have to maintain the records or details of the maybe their raw materials and so on. In this chapter, we are going to learn the problem solving techniques or methods using computer. This chapter deals with the problem solving over computer. So, this same thing we can apply to different discipline or different fields to solve different types of problems. It involves many steps or many stages, different tools in order to solve a problem. So, involve tools, the different tools like algorithm, flow chart, etc. Here the programmer or user has to follow, he has to follow these steps or instructions in the order to solve a problem, in order to solve a problem or to come to a conclusion. Not only that, it has a process of analysis, diagnosis, and so on. So, this is just introduction to problem solving methodology. So, students, I repeat once again, we are using the term problem solving in different discipline or different fields. You take an example like in the field of science and engineering, it deals with mathematical problems. And if you talk about education department or institutions, as I told you just now, that is to keep track of or to maintain the data records of all the students of a particular institution. In commerce and in the field of business, again it is to process very large amount of data. In the field of commerce or in the field of science, it has to process large number of data or the data is very voluminous. Very good example for this is Aadhaar card. Your Aadhaar card. See, as and today, every citizen of India must have an Aadhaar card. Now you can imagine the process of getting Aadhaar card and how to maintain the records of Aadhaar card, or who is going to maintain the records of Aadhaar card, where they are going to maintain the records of Aadhaar card. Because if you look at the citizen of India and you can calculate the total population of India, and it is a very large number. So that is the reason. So we are using problem solving in many fields. This chapter deals with how to solve a problem using computer. So we are applying the programming concept through computer to solve different types of problems. It has many steps or many stages, and also it has its own tools like algorithm and flowchart. And here the user or the programmer one has to follow these steps or instructions in the order to arrive at a conclusion or to solve a particular problem. And it has also a process of analysis or program analysis and as well as diagnosis and so on. So this is about the problem solving methodology. Now let us look into that. What are the steps involved in problem solving methodology? Steps involved in problem solving methodology are: first one, problem definition. Next one is problem analysis. Next one is problem analysis, algorithm or flowchart, coding. Fifth one is testing and debugging. Finally, documentation. Students, the steps involved in problem solving methodology are: First one is problem definition, second one is problem analysis, algorithm and flowchart, coding, testing and debugging, and documentation. We have to follow these steps in order to solve a problem over computer. Now let us learn these definitions one by one. So first step is problem definition. Problem definition. Problem definition is nothing but to define the problem. It is to define the problem. Or in other words, it is nothing but to state the problem, in such a way that problem should be very clear, easily understandable, and unambiguous. What is required for this problem to get a proper solution. In order to get a proper solution, students, this problem definition is nothing but to define the problem. What do you mean by define the problem? Nothing but we have to state the problem, or we have to mention what exactly the problem is. So it should be in such a way that the problem, what we are going to mention, what we are going to state, it should be very clear. And easily understandable to the programmer or the user, and unambiguous means there won't be any confusion. Unambiguous means to avoid any confusion. And in the problem definition, we have to say that what exactly we require for this problem in order to come to a conclusion, or in order to get a proper result, proper solution. Very good example is, sometimes we have heard from many students in the examination, some student complained that this question was not very clear. It is not a direct question, it is an indirect question. And with respect to mathematics, we have heard that, oh, this problem is wrong. See, so many things we have heard about a question in the question paper. In the examination, if you don't understand the problem or the question very well, you are not able to answer the question properly. So then you will be in a confusion. So that is the reason. What is the problem definition? It involves to define the problem in such a way that the user or the programmer must understand the problem. It should be clearly stated, and there should not be any confusion, and user or the programmer must clearly know that what is requirement for this problem to arrive at a proper solution. So this is problem definition. Second step is problem analysis. So what is problem analysis? This problem analysis involves identifying one is input or types of data, and second one is what is the output. It is nothing but desired result, and third point is additional information or some conditions or constraints involving in a problem. So friends, this problem analysis, it involves identifying the input. You know what is the input? Input is nothing but the data what we are feed into a computer in order to get a proper output. So we should know what type of data we have to enter. Data may be a number or decimal number, or it may be a picture, a graphic, so on. So first of all, we should know what exactly the input we have to feed into the computer. Second one is, we should very clear about output or the result, desired result. What we exactly want from this problem, or at the end of a problem solving approach, what is the result we get, that we have to be very clear. And next one is additional information or condition or constraint. We may have to look for some additional information, like what is the condition of this problem. So whether can we use these type of values or another type of values. See, based on certain conditions, we have to use the proper, whether it has been given permission to use these type of data or another information. See, all these are nothing but additional information. Suppose if I want to find out area of a circle, you know what is the formula? Area of a circle is A is equal to pi r squared. Here, in this example, in order to find out area of a circle, we should know the value of radius, isn't it? So here in this example, we have to input value of radius in order to get the area of circle. So in between there is one more value that is called pi. It is nothing but a constant. It is a constant. So we know the value of constant. It is either you can use as 22/7 or 3.1416. So these type of information is nothing but your additional information with respect to or when the problem is concerned. This is about problem analysis. Next step in this process is design of a solution. Design of a solution. What is design of a solution? This is nothing but to planning a solution. As all of you know that computer is a machine. Everything we have to, or the programmer user has to provide all sorts of information. So here, even to solve a problem over computer, the user, the programmer must know how to solve a problem. This is nothing but planning or designing a solution. This is nothing but representation of solution to a problem. Solution to a problem using tools such as algorithm and flowchart. Algorithm and flowchart. The user has to plan a solution for this problem by using different tools such as algorithm and flowchart. See here, a very simple example is to construct a house or to construct a building, first it has to be pre-planned. So architect or engineers, they will plan your house or plan your building. So here those type of planning is nothing but design of a solution to a problem. In order to solve a problem, the user must have its own plan to continue with the process. That is nothing but design of a solution. Now let us see what is an algorithm. What is an algorithm? Algorithm is one of the tool in designing a solution. So algorithm is nothing but it is a textual representation of a solution to a problem, and it involves step by step procedure or instructions to solve a problem. to solve a problem. So, what is algorithm? Algorithm is nothing but a textual representation of solution to a problem, and it is nothing but step-by-step procedure to solve a problem. So, for example, you take example, I want to find simple interest. To find simple interest. See, in order to find a simple interest, or if you want to find out what is simple interest, we should know the formula first. That is SI is equal to PTR by 100. And in order to solve a problem, or in order to get simple interest, the user or the programmer must enter the values of PTR, that is principal, time, 100. Then he has to multiply all these things, divide by 100, then you will get the solution, or you will get the simple interest. So same thing we have to write in text, or in the by step by step. That is algorithm. For example, first we will start an algorithm. Here step 1. What is step 1 here? Step 1, in order to find out simple interest, we should know the value of PTR, or we have to enter value of PTR. So we will write here input PTR. This is step 1. So after this, step 2. What is step 2? Step 2 is nothing but applying formula. We have to apply formula. The formula is SI is P into T into R, whole thing divided by 100. See, this is we are applying formula. Here we should know that P multiplied by T multiplied by R and whole divided by 100. This is the formula. So second step is applying formula. So step 3 is we have to output simple interest. So this is step 3. Once we have arrived at the result, this ends the problem. We are going to end here. So this is very simple example of an algorithm to find simple interest. It can also be written as first start step 1. Step 1 is enter values of PTR. Step 2 is applying formula. That is SI is equals to P into T into R, whole thing divided by 100. Step 3 is print the result, and this algorithm has to be end at particular stage. So this is algorithm. Next one is flow chart. Okay. What is a flow chart? Flow chart is nothing but a diagrammatic representation of solution to a problem. So what is a flow chart? Flow chart is nothing but a diagrammatic representation of solution to a problem. It is also a step-by-step procedure to solve a problem. Algorithm is nothing but a textual representation, but it is diagrammatic representation. We are using some geometrical shapes like oval, rectangle, This is rectangle and parallelogram. Parallelogram and arrows. These are nothing but flow lines and rhombus. So on. To represent solution to a problem through flowchart, we are making use of some geometrical shapes like oval and rectangle, parallelogram, rhombus. These are arrows and even circle. All these different shapes we are making use of to draw a flowchart to represent a solution to a particular problem. You can differentiate algorithm and flowchart. Algorithm is nothing but a textual representation, whereas flowchart is diagrammatic representation to solve a problem. Let us write a flowchart to find simple interest. To find simple interest. The first step 1 here is we have to start flowchart. We using this oval shape to start a flowchart. And what is step 1? To enter values of PTR. We are using parallelogram. This is for input. We say input P, T and R. This is. So next step is applying formula, that is nothing but processing. So here we are writing the formula SI is equals to PTR divided by 100. Second step. And final step is we have to output the result or to print the result. We are using parallelogram, and here we can write here output simple interest, and it has to close it with the help with stop here. And these are step 1, step 2, step 3, and all these steps are connected by using flow lines. This flow line indicates flow of instructions or flow of logic. So this is a simple flow chart to find simple interest. Students, we are going to learn algorithm and flowchart in details with different examples. Next step is coding. What is this coding? Coding is nothing but translation of an algorithm or flowchart into a program or into a syntax of computer language. So students, what is coding here? In previous step, it is design of a solution. That is, we used to write an algorithm or flowchart. And of next step is coding. Coding is nothing but translation of an algorithm or flowchart into a computer program. Is nothing but by looking at an algorithm or flowchart, we have to write a computer program. So this computer program we are writing by using a computer language, that is high level languages. You know that. In my previous sessions, you know different types of languages. We have different levels of language like high level language, machine level language, as well as assembly level language. What is the coding now? Coding is nothing but writing a program by making use of high level language. We have different high level languages. They are basic, COBOL, Fortran, Pascal and C, C++, Java are few of computer language or high level languages. So after algorithm and flowchart, next step is coding. It is nothing but writing a program by making use of any of the computer languages. Next step is testing and debugging. Testing and debugging. So what is testing here? Testing is nothing but run the program or execute the program. Execute the instructions of a program by entering sample data and check the result or output, and also check the logic of the program. So students, what is testing here? Testing is nothing but we have to run the program or we have to execute the program. See, in previous step we are coding. In coding we are writing a program for computer by using high level language. After the program has been written, that program has to be executed. So the meaning of testing is nothing but we have to execute all instructions or commands of a particular program. Then not only that, we have to check our program or we have to test the program by entering different values of data or different types of data or different sample data. We have to check it, and also we have to check the result or output. Are we getting a proper output or desired results? We have to check the logic of the program. Logic is nothing but flow of the program. I mean, whether we are getting for these type of input, are we getting the right output? Testing of a program, it involves execute the program and run the program with different sample data and check the result and also the logic of the program. So this is testing. Next step is debugging. So what is debugging? Debugging is the process of checking and correcting the mistakes nothing but errors in a program. So this is debugging. What is debugging? Debugging is nothing but checking and correcting the errors in a program. Once the program is written, it has to be checked for errors. So that process is called debugging. So it is a process of checking the errors or checking program for errors, and if at all any errors, those errors has to be, or those mistakes or errors has to be corrected. That is the process of debugging. And here when you talk about errors in a program, we have different types of error. They are syntax error, semantic error, logical error, and runtime error. In a program, we can come across different types of errors. They are syntax error, semantics error, logical error and runtime error. Students, let me summarize what we have learned today. In this session, we have discussed about problem solving methodology, the steps involved in problem solving methodology. They are problem definition, problem analysis, design of a solution. It involves algorithm and flowchart, and testing and debugging, and documentation. We have learned the definition of problem definition. It is nothing but defining the problem or understanding the problem very well. Second step is problem analysis. Here we have to identify types of input, types of output or desired output, and some additional information to the problem. And next step is designing a solution or planning a program. That is, it involves tools such as algorithm and flowcharts. What is algorithm? It is a textual representation of solution to a problem, and flowchart is a diagrammatic representation of solution to a problem. In flowchart, we will make use of different geometrical shapes like oval, rectangle, parallelogram, etc. Next step is coding. Coding is nothing but translation of algorithm into program, or we have to write a program for a particular problem with the help of computer language, any of the high level language. Next step is testing and debugging. Testing is nothing but we have to check the program written for or with different types of data, and we have to check the output. We have to check the logic of the program, so on. That is testing. Debugging is nothing but the process of finding out or identifying the errors in a program and correcting those errors. And here, as I told you, we have different types of errors. They are syntax error, semantics error, logical error and runtime error. Students, let us continue with the remaining steps in my next session. Thank you very much.